There's a dark scar on the sun right now so large that you can see it yourself. No telescope, just a pair of eclipse glasses and a clear sky. That's not an exaggeration. Scattered across what you're looking at, those dark blotches are sunspots, and each one of them is already bigger than Earth. They're dark not because they're cold exactly, but because they're cooler than the surrounding surface. The photosphere around them burns at about 5,500 degrees Celsius. The spots themselves sit closer to 3,800. That difference is enough to make them look almost black by comparison. Wrapped around each dark core, that umbra, you can see those brushstroke lines radiating outward. That's the penumbra, and those fibers are plasma being dragged along magnetic field lines so strong they physically suppress the normal boiling of the solar surface. Now look here at the lower left of the frame. This is the heart of active region 4478, a large dark core with multiple umbral patches surrounded by those thick, swirling filaments. The whole cluster here spans something close to 200,000 kilometers across. Earth's diameter is about 12,700 kilometers, so we're talking a structure nearly 16 Earths wide. The photographer, Alfredo Vidal Perez, captured this from Barcelona, Spain, in visible light, not with some space observatory, but from a city backyard. That tells you something about just how extreme this region is right now. And here across the image, between the big clusters, you can see this ragged chain of smaller spots and dark pores stitching everything together. That connection matters. It's a sign that the magnetic field threading through this whole region is tangled. Positive and negative polarities knotted up next to each other. When those fields snap and reconnect, they can hurl billions of tons of charged plasma into space. Scientists call those events coronal mass ejections. If one of them points toward Earth, it can mess with satellites, nudge the atmosphere just enough to throw off orbital calculations, and surge through power grids. The flip side? Auroras. Bright ones push down toward latitudes that almost never see them. What gets me is that this isn't happening in some archive. It's on the sun right now, in June of 2026. The same region producing these swirling magnetic storms is the one you could step outside and find with eclipse glasses before the day is over. That's a rare kind of connection between a photograph and your actual sky. We'll be back tomorrow with whatever the data shows next. Subscribe so you don't have to remember to come back.